Hi all! Let's look at how to find greatest common divisor by factoring. A greatest common divisor, GCD, is the largest value that can be evenly divided into two or more numbers. GCD is most commonly used for reducing fractions. To find GCD by factoring, first you want to factor each number given to you. Then you want to compose a number out of factors that repeat in each of the given numbers. Then you want to multiply factors to get the GCD. As an option, you can always check by dividing each given number by the GCD to make sure you get a whole number as the answer. So let's find GCD of 120 and 270. So let's factor 120. We can say that this is 12 times 10. 12 is 2 times 6. 2 is a prime, so we circle that. 6 is 2 times 3, so we have 2 more primes. 10 can be factored into 2, which is a prime, times 5. And we are done with factoring 120. Let's factor 270. So we can say that this is 27 times 10. 27 is a 3 times 9. 3 is a prime, we can circle it. 9 is 3 times 3. 10 is 2 times 5. Okay, so now that we have factored 3's and everything is in terms of primes, we can calculate GCD. And we do that by selecting common factors. We have a 2 in 120 and we have a 2 here. So our first factor in common is a 2. You can only take 2 at a time. You make pairs and you do not reuse the factors you have picked out. Then we have a 3, and this 3 repeats also. So we have 3 as another factor, and we have a 5 that is in common, so times 5. Since we have no more factors that can be matched up, we can calculate our GCD, which will be 2 times 3 times 5, which is 30. If you want to check, you can take 120 and divide it by 30, and we can also take 270 and divide it by 30, and we want to make sure that this reduces into a whole number. So 120 divided by 30 simplifies into 4, and 270 divided by 30 simplifies into 9. I got whole numbers as my answers, so I know I did it properly. Let's find GCD of 12, 16, and 40. 12 is 3 times 4. 3 is a prime. 4 can be factored into 2 times 2, so we have our primes for 12. 16 is a 4 times 4. Each of them can be factored into 2 times 2. So these are factors for this. And 40, we can say it's a 4 times 10. And 4 is a 2 times 2. These are prime. 10 is a 2 times 5. And these are prime. Now let's construct our GCD. 12 has a 3, but the other two numbers do not have 3, so I cannot use that. It has a 2. We can match it with this 2 in 16 and this 2 in 40. So our first factor in common is a 2. It has another 2. We can match these 2's. Doesn't matter which ones you match, as long as you don't use them again. So we have another 2. There are no more factors that are in common in all 3 numbers that can be reused. So our GCD is 2 times 2, which is 4. Let's find GCD of 12, 15, 21, and 27. So the first thing to do is factor. 12 is a 2 times 6. 2 is a prime. 6 is 2 times 3. We're done with this. 15 is 3 times 5. Both are prime, so we're done with 15. 21 is a 3 times 7. And 27 is a 3 times 9. So this is a prime. And 9 can be factored into 3 times 3. Now you can look for GCD, and that will be common factors. So we have a 2 in 12. There are no more 2's in the other 3 numbers. So let's look at the 3. We have a 3 in 12. It repeats here, repeats in 21, and it repeats in 27. So 3 is our common factor. There are no more factors in common, so our GCD is 3. Let's find GCD of 9 and 8. 9 can be factored into 3 times 3, and 8 can be factored into 2 times 4, and 4 is a 2 times 2. So let's find our GCD. Now, 9 has 3 and 3. 8 has only 2 times 2 times 2. So they have no factors in common, except each of them can be divided by 1. So if you have no common factors in your factor trees, remember that each whole number can be divided by 1 and you still get a whole result. That's all.